Winner,
We do titrations and add to calculate
we did what?
the at-
We
and
did
the
what?
volumetric analysis. Analysis.
Okay, very good. So today we'll be we'll continue from where we stopped from in the last class. Remember I told you guys that we have um two kinds of practical analysis you do, qualitative and quantitative, and based on your wire yellow paper, you have volumetric analysis, acid-base titration um for your quantitative process, which we have dealt already with that in the last class and the class before the last one. So in this class, we'll be talking about the quantitative analysis aspect for you guys. Can you all see my screen?
Yes, ma.
All right. Now, like I said in one of the previous classes, qualitative analysis have to do with qualifying a particular um, the presence of certain ions or certain reagents, compound, like knowing the presence of something, okay, through different steps that you will be asked to follow. Okay, so it is just like helping or the steps you follow in identifying a substance or components of substance present in a particular sample. So we could be for qualitative analysis process, we could be analyzing inorganic substances. Okay, when we say inorganic, they are um compounds, elements, ions that are not organic. That is, they are not composed of carbon and its component compounds. Okay, so it could be most of the other elements in the periodic table. So we could be testing or trying to identify the presence of chlorine, of different other gases, of metals. Okay, so we can be testing for all these things. Now we also have organic qualitative analysis where we go over to carbon and its compounds. Okay, for this one, you would see we will be dealing with different homologous series, okay, such as alcohols, the series of alcohols of alkane. We could be searching for testing for starch, proteins, and things like that. That's organic. And then we also have other different ones, okay? But for you people now, these are the ones you will likely be examined for, right? So in qualitative analysis, we have to observe and we have to make conclusions. All right. Now, observations could be color. It could be in terms of color. It could be in terms of odor. It could be in terms of solubility. It could be in terms of physical appearances. Okay. These are things we would observe when we carry out qualitative analysis. And these observations are what will help us carry out our conclusions. So how do you now know based on observations? You must have studied before now and you know already how different elements or different compounds act. Okay, what is it about them that helps us to know their identity? Okay, every ionic substance have its own identity. So for example, you should have read things like different tests for gases. Okay, gases like oxygen. How do we test for oxygen? How do we test for carbon oxides? How do we test for sulfur oxides? How we test for oxygen? Okay, I already mentioned oxygen. Or for hydrogen. All right. And then test for metals. How do we identify different metals? Okay, these are things you should have already done maybe in your previous classes. What is the color of a sodium metal? If we are testing for it, what color helps us to know that this is sodium? What color helps us to know this is potassium? So they are different. Those are flame in terms of flame tests, right? So all these are different tests that chemists have undergone to know what this gas represent or what this element represent and what the other one represents. Okay, so for yourself, for you people, we are we will be dealing with, let me open the notes. See it here, one of your specimens. Okay, one of the labeled reagents you'll be working with, okay, is your lead 2 carbonate. That's what we can see here. Lead 2 carbonate, and you also be working with starch. They are what mixed together. So this is what we'll be working with. Okay. And what you'll be working with this year. Now, lead 2 carbonate. This is lead 2 carbonate, PbCO3. Okay, that is the formula because it is composed of lead, Pb, right? And this is the charge for lead, and it's also composed of the negative side, okay, of the negative carbonate, 2 minus. So to get the formula, when we do the crisscross method, it will be Pb2 and CO3 2. The 2 is cancelling out the 2, so we have PbCO3. Now this is lead 2 carbonate, and it's an inorganic salt. Okay, so our test process, we know that we are making use of a salt. Okay, and then starch. The next thing, starch is organic in nature, right? Starch is a kind of carbohydrate, a complex carbohydrate, and it is not a salt. Now, in this process, the starch and the salt, okay, it's more like sugar and salt being mixed together, right? Because starch is a sugar component, a sugar substance. Okay, so they are being mixed together, and you'll be given different steps to follow. Okay, now as a chemistry student, for this kind of qualitative analysis, it, what we were expected to do is to, while the experiment when goes on, you are to take note of the steps, right? And that is what you would write in the first column as your test. And then you are going to put down your observation in plain terms. Okay, no long or too much explanation. Straightforward putting down of your observation, and then inference. Okay, so that is to say, what does this observation implies? Okay, what conclusion have you drawn after getting these observations from these steps of the test? So your question manual would likely be giving you the steps to follow. Okay, they might ask you to mix this with this. What you observe when this is mixed with this, you will write it. What is the conclusion? What does that observation imply? You would also put it down. So now this qualitative analysis is simply, the aim of it is for us to test for the presence of each or every component of that mixture. We know that the mixture is made of starch and lead to carbonate, right? So we are going to be since lead to carbonate, PbCO3, is ionic in nature because it's made of a positive and a negative end. Okay, so that is to say, when it is being when it is in a solution, it will form ions. Okay, so it is now going to be having a positive charge lead and negative charge carbonate. Okay, but starch is not ionically bonded. It's not an ionic compound. Okay, it is covalent. After all, it's an organic compound. It is a carbon compound, so it is covalent in nature, and so it doesn't form ion in a solution, and so there will be no splitting. Okay, so if we have um we already know that starch is complex carbohydrate. So if we have starch to be this is simple. Okay, so there is no way this is going to be splitting to be forming a negative or a positive side. Okay, so in essence, we are testing for the presence of this Pb, of this CO32 minus, and of this starch as a whole. Okay, so we should ensure that in all our processes, we are going to show at least the presence of these components of our mixture. Okay, we're going to write the observation that helps us to know that these are what are present. Okay, so cation is the lead, the anion is the carbonate ion, and then we have the starch. Now, for these processes, when we see carbonate ion, what comes to mind? What can easily come to mind is test for carbon dioxide, test for carbon. And a very common thing that comes to our mind in terms of test for carbon is, you remember the gas test where you say, oh, carbon turns lime water milky. Okay, so this is one of the things we would aim to observe. Okay, all right. So this, let's just go right into the analysis process. Now, one of the steps we can take to test for any of the components in the mixture, okay, is our labeled substance, our labeled mixture. Now, in your examination, your labeled mixture is going to be having an alphabet labeling, okay? It could be A, it could be B, it could be C, all right? So you take note of the labeling it will be given to you, because you're not only making use of these things, you're also carrying out an acid-base titration process. So you take note of the one that is having this label. So let us assume it, okay, just as it is in the manual I showed you earlier. Assume it to be C also for you, okay? So one of the test process we can take is that the mixture labeled C, so you're not going to be saying mixture plus this, or you're not going to be saying lead 2 carbonate plus this, or you will not say the salt plus this. You would identify the mixture of lead 2 and starch. You would identify that mixture as C. Okay, so when we add this to distilled water, we could add it to distilled water and shake it properly. Please, can you confirm if you can still see my screen? And if you all are following up to this point.
Yes, ma'am.
All right. So this with distilled water, and we shake thoroughly. Okay. Now, this is a virtual class. So probably or likely your school might carry out the process for you before your examination. Okay. So that's when you see what will actually happen when this mixture is being mixed with distilled water that is now in a solution and is being shaken thoroughly. So what we would observe is a white insoluble mixture. Okay, so we can say a white insoluble mixture is observed. Straight to the point, right? And then our inference is what what are we going to conclude from there? We can't conclude from here that lead is present or carbon. No, we can't conclude from here. We can only conclude that if C, okay, because this is actually an insoluble salt. So when we are dissolving this mixture, right, in water, and we see that a white insoluble mixture is observed, that is like a precipitation process. Okay, so there is no dissolution whereby the mixture, okay, is totally mixed with the water. So what this just simply tells us is that C contains an insoluble substance, okay, or rather C contains insoluble substances. So that's what we're going to be concluding in the first step. Now, another probable step we can follow, okay, is we can be told to add C with dilute HCl, okay, dilute hydrochloric acid or probably one other um strong acid. Okay, so now in this step we are going to be observing um two things. Okay, one, we are going to be observing an effervescence. Who knows what effervescence means? Yeah, someone should tell us.
This is like bomb.
It's like what? It's like bomb.
Bubbly.
Hello? Okay,
Like
bubble. Yeah. Yes.
bubbly.
Yes, that is correct. So this one thing we are going to observe. A second thing we are going to be observing in this, that is what effervescence means. She's correct. A second thing we are going to be observing in this process is a effervescence observed, okay, and a colorless and odorless gas. Ev- Odorless and colorless gas and the colorless and odorless gas is evolved. Okay. Now, how do we know what this gas is? Because it's not the only gas that is odorless and colorless. There are so many odorless and colorless gases, right? So, if we will have to now test this gas as well. So, but then again, these are the two main things that have been observed in this process. Okay, now this colorless and odorless gas, when passed through lime water, it turns it milky. Okay, odorless and colorless gases is evolved, which when passed through lime water, turns milky. Okay, can someone tell us what will be our inference from this observation?
Hydrogen ion.
Okay, that's a good try. But this is why it is not hydrogen ion. Lead, we're dealing with lead 2 chloride here, right? So now if the lead 2 carbonate rather, if our lead 2 carbonate, they said we are talking about its reaction specifically now, not the starch. Okay, if our lead 2 carbonate is reacting with HCl, right? This is going to be giving us a salt, okay, water and carbon dioxide. So this lead 2 carbonate is a metallic carbonate, a metallic tricarbonate. So it's like going to be acting as a base here, right? and our acid is the acid, so it will be giving us a salt, lead chloride, plus um CO2 plus our H2O. This is the product we will be expecting in this second step. So there is no, in all of these products, right? This H2O, of obviously it's liquid, it's water, right? And this lead chloride is our salt, okay, which is actually aqueous, okay. And then of everything here, CO2 is the only gas formed in our products in this step. So there is no sorry, hydrogen, or what did you say? Was it hydrogen or oxygen you gave it as answer? That there's none of that formed in the products. So the gas that is formed when this lead carbonate reacts with HCl is CO2. Okay, so and it is CO2 in our gas test for gas, right? It's CO2 that turns lime water milky, not hydrogen. Okay, hydrogen is giving a pop sound when littered. Okay, that's for I. Then oxygen is glowing splint. These are like keywords we used to know their tests to observe if it is a test, if we're getting hydrogen or oxygen, right? But for carbon dioxide, it turns lime water milky. Okay, so it's going to be giving us a milky color over lime water. So in this step, our inference would be a carbonate ion, presence of carbon. So we're going to say carbonate ion, okay, is our CO is present. Okay, because this carbonate ion is present due to the effervescence observed, right? And then also CO2 is the gas that is evolved. CO2 evolved. Okay. And then our starch is still there, insoluble. Now another test that we can do here, okay, so remember I said our salt is ionic, right? So we have done the test that helps us to know that there is carbonate ion in there. So it's remaining for us to do tests that will help us to know there is lead ion and also help us to know there is starch ion indeed present there. So another step that you can be given is to filter the mixture, right? And eat or allow it to cool. Remember, this mixture is insoluble, so filtration process can actually occur, right? When something is dissolved in a solvent and it's insoluble, it's going to gather up at the bottom. Okay, it's not going to dissolve and mix up totally with the water. That's what makes it insoluble. And so this thing can be filtered going through a funnel, for example. And when it is filtered, just the liquid goes in, and we just have the insoluble solid that settled at the bottom to be in the funnel, and we call that the filtrates, right? So now we're going to be separating the filtrate, because remember it's uh, uh, our insoluble starch is still there. still an insoluble mixture. Now the third step we said you should filter the mixture. Okay. Then maybe you can be asked to heat the filtrate and allow it to cool. Now in this step, a white precipitate will dissolve on heating and it will reappear, okay, on cooling. Okay, so we know that, like I said, when we filter, the substance that is remaining in the funnel is called what? Residue. And what is being filtered at the liquid is what the filtrate is. So now it is this filtrate, okay, that would also still be containing mixture of, it won't be just a single component because it was one substance dissolved in another already before. Okay, so that filtrate is what we are going to heat. Now when we heat the filtrate and we cool it, on heating it, white precipitate, okay, will dissolve. That is going to be mingled everywhere, okay, and then it will now reappear, settling down at the bottom again after cooling. So a white precipitate, that's what it does. It makes particles to to be in motion, and so precipitates won't be settling. It's unlike when the component is cooled, everything is settled. It's just like in a dirty water also, for example. When or a water that has some particles in it, when the water is boiling, you would see it's as if the particles is actually dissolved in water. Everything is moving at motion because of the heat, right? The energy in it. But when it's being cooled, everything settles back at the bottom. Okay, on it and reappears on cooling. Please, I hope you all are jotting down. Now, this precipitate there tells us the presence of lead 2. I hope you all are jotting down. Okay, so this is one of the steps we can take. Okay, another step that take notes in your examination, any of these steps, you can be told to test any of these steps. All these test process is not something that will come from your memory. Okay, this test 1, test 2, test 3 that I wrote at this left end is not something you would invent on your own. Okay, is what your exam question is, what your question is going to ask you to do. So you don't have to memorize them. You just have to know what will happen when you carry out that step. You'll be instructed on the step to follow. So what if you're being told that the filtrate, so maybe probably instead of this test 3, you can have something like um these other tests to replace it. Okay, we can be told that the filtrate, okay, rather than the eating it and allowing it to cool, another step that we can do to observe our lead to ion, okay, could be the filtrate being mixed or reacted with our NH4OH, okay, ammonium hydroxide, okay, in drops and then in excess. This is another step we could be asked to take. Now, in this step, the same thing, white precipitate can be formed, okay, and then the precipitate is insoluble when in excess. This also shows us the presence of lead 2 ion. Or instead of this step, we can be told to react our filtrates with sodium hydroxide. Okay, in drops, the same thing, and then in excess. Now in this step, the same thing. Okay, white precipitate is formed. The precipitate will dissolve. Not exactly the same thing, by the way. Okay, let me just write it. White precipitate is formed. Okay, and then the precipitate dissolves in excess. Okay, remember the first one is not soluble, but this one dissolves. So it's a different case with sodium hydroxide. Shows that this one is present. Okay, so remember that initially we had okay, let me ask this question. We've not tested for our starch, okay? We have seen different steps that will help us identify the presence of lead and of carbonates, okay, which is in our organic salt. How about our starch? Where did our starch go to? Can anyone tell us and give us an idea of how we are going to test for our starch? Yes. Okay, so one of the steps in your examination can be, okay, since your examining your we already know you're going to be making use of starch, right? There will also be a step that will help you identify the presence of starch. Okay. Now, how do you test for starch? Who knows? What reagent do you use to test for starch? Iodine solution. Remember we filtered out residue then, right? Okay, so at this step, okay, we're going to be having, it should be 5 or 6, and this is about 7. In this step, we're going to be having a portion of our original mixture. Okay, being plus our iodine solution, mixed with iodine solution. Now, when we are testing for starch, a starch solution with iodine, a starch with iodine gives us a blue-black coloration. Okay, it's the normal test for carbohydrates you did in school. Okay, so this tells us when we see a blue-black coloration, this observation is based on color, right? The top ones, this one is based on solubility, okay, and so on. So starch is present. Okay, so that is it. So we are being able to identify the components of our mixture. We have been able to identify the presence of lead, of carbonate, and of starch by these 3 methods, by these steps rather. Does any of you have a question? Ask your question. Have you all jotted down this whole process? If you have a question, please ask.
Are we going to do the practical by ourselves?
If you're going to do the practical by yourself, normally in WAEC, candidates will be given their own reagents to work with, right? But based on the situation and country we find ourselves in, I don't think you will necessarily be given those things to do individually. Okay? So it's your teacher that is going to help control the process, right? So I feel like it depends on, especially also, it depends on how your school has been operating. You are not the first YA candidates, right? So I doubt you are going to be the one handling it all by yourself. Your teachers will be there to guide you. You might be given your own apparatus, your own chemical to work with. That's how it is normally done. But not all schools do that. Some schools, they will do the practical. Your teacher will do the practical with you, okay, separately before the time for the exam. Then the time for the exam is just for you to go and write what you observed from the practical that you have already done. Maybe a day before that day, before the day gone. So it just depends on how your school operates. Or anything that wants to go on, your school, your teacher already knows what and what. you please. So your own parts, the role you are supposed to play is to study. Since you know that your reagent, one of them is going to be lead carbonate and mixed with starch, you should study the test for these individual things. You should study and know what you're supposed to observe so that if your school is going to give you an actual practical, you know what is going on there. But it's nothing to be scared of. There's nothing extraordinary there. Um, and since also you know that you're also going to be doing titration process, right? Working with acid and a base, you should go and get yourself acquainted with how titration is done, the calculations, because actually the calculations are the main thing in titration, not even the experiments per se. Values are manipulated. Okay, so you can do an experiment and you get weird values. At the end of the day, you should know the values that would should work for you in giving you a good and more accurate answer and closeness to having good scores. So preparedness is the key, not what you do with the practical items. Preparedness and knowledge of what's going on is the key. Preparedness and knowledge of what you are expected to write is the key. Okay, I don't think Waye goes to ask where is the things Winner used to do her own practical that she used to get her answer. All right, so that's it. Any other question? Do you have a question? Okay, no question. So Winner, do you get it now?
Yes, ma.
All right. So since no question, I should ask a question, right? Your chemistry examination is on the 20th, if I'm not mistaken. Is that when? Is that the time?
Yes, ma.
Oh, okay. So when is the actual exam, not the practical now? The essay exams, the written exam. Do you know?
I don't actually know, but
Okay.
I know that I think it's June.
I'm struggling to hear you, Winner.
July 11,
It's May 11.
June, June 11, June
June.
11.
Okay, okay, yes, yes. June 11. So what topic do you want, or you people want us to deal with in the next class? Because we have said quite enough of practical chemistry. Just have to go and study your book, study and get prepared. Know what to expect. What do we do in the next class? What topic should we learn? No one is saying anything.
Equilibrium.
So I should pick the topic by equilibrium. All right, that's a good one. Okay. All right. Next Monday we'll go into equilibrium. Um. So in summary of what we have done today, okay, qualitative analysis, right, where you test the quality of the different substances that can be present in a mixture or a sample, okay, and then we will be giving some steps to follow, and is the steps that you will write as your test in your test column. This first column we have here. From there, we have observation. It's what you observe. It can be color, it could be solubility, it could be smell, that's the odor. Okay, write your observation straight to the point. And then your inference is what this observation has implied. Okay, what your conclusion is based on the observation. Not all the time that in inference this thing is present, that thing is present. You can just have a simple conclusion, not necessarily stating that something must be present. Like in the first step we took here, you say C, which is the sample mixture, contains insoluble substances. That is what we got from the first observation alone. Now, um, okay, so that's it. So you can go and read more about different ways we can test for the presence of lead ion. Okay, and also carbonate is usually the effervescence, and also by turning lime water milky. And then iodine solution is what we usually use to test for starch. Okay. All right, so that's all we have for today. So this year, and also in addition with what we did last time, which is titration. Okay, you should know when to use this formula or that formula. Okay, we should know what values we are going to be using. Values should be concordant, having a 0.2 difference, maximum of 0.2 difference. Okay, and then also we should know when to use the formula for concentration, this general formula. Okay, or and when to use the formula of mass concentration is equals to, sorry, molar concentration equals to mass concentration divided by molar mass. Okay, that formula should be when our mass concentration is already given and it is saying gram per mole. But when we have no gram per mole, okay, we have to have our concentration of either the acid or the base in mole per dm cube. and we should always take note of our units. Now, in a situation like this, for this first general formula, right, the um volume can be in centimeters cube and the concentration can be in mole per dm cube. Even though this dm cube tells us about the volume, okay, one volume in that mole, we don't have to convert the centimeters cube to dm cube, provided the vb is also in centimeters cube. Okay, so the time that we will need to convert is when we are dealing directly, we are dealing with a formula like this. We are trying to look for number of mole, n equals to cv. We are dealing with something like this and we see our concentration is in mole per dm cube and our volume is in centimeters cube. We have to convert our volume. Why? Because number of mole is in mole. The unit for number of mole is mole. So if we are working with this formula and then we are using centimeters and dm cube, it's contradicting each other. And so our unit will no longer be mole because dm cube cannot eliminate cm cube because they don't have the same weight. dm cube is larger. Okay, so that's why in this one we have to convert because our n is number of mole measured in mole as the unit, but n in this one here at the top is just mole ratio. We can get what it is from our balanced equation, from just the coefficient. So we don't have to struggle to be converting and converting. I hope you all understand what I'm saying. So we have to take note of that. And also take note that the readings we are getting from our burette, okay, whatever we are pouring into the burette is what is going to give us our is the whatever we are going to be pouring into the burette, okay, is where we are going to be getting our volume from. So for example, if our question is going to be telling us that our acid is what is going into the burette, it means that our readings will be that of the acid. Okay, and so we are going to be getting our volume of the acid from the burette. But if our acid is being sucked from the pipette, it means that our volume of acid will be 25 centimeters cube, which is our volume of our pipette. Okay, so wherever the chemical is going to tell us where we are going to be getting our volume from. So the titration process gives us those two details: volume of acid and volume of base. If we are pipetting acid, means our volume of acid will be 25 centimeters cube, if that's the pipette we choose to take. And then if we are pipetting base, means volume of base will be 25 centimeters cube. But if our acid is in the burette, it means all the readings we take from the burette, we are going to take the average, and that is how we are going to know the volume of our acid. If it is base, that's how we're going to know the volume of our base. So those two informations are what the titration process tells us. If we get those two details, then we are good. We calculate the rest things by ourselves. The titration will not give us those rest information. We just need the volumes to give us the rest information and know what pure and the impure component is. The pure one is the one that was given to us, okay, is the concentration or the solution given to us before dilution. Now the impure one is when is what we are calculating. So our calculated value after being in a solution. Okay, so that's it. Since no more questions, I hope we have understood each other today, and I hope you all have learned something today. Have you all learned something today? No one has learned anything today. All right. That's fair enough. Okay, that's all for today. Bye bye. Thank you.
Thank you, ma'am.
Bye. Thank you.